Hello friends, today we are going to show you the implementation of feature extraction algorithm on FPGA board. So let's start with the algorithm. Basically in feature extraction, we extract the points on the pixels on the image which have a major change of intensity. So basically corners are the best places in an image where we can have feature extraction points. So this is the basic algorithm for feature extraction. So we have gone through this algorithm and we have implemented each step of this algorithm in FPGA and MATLAB. So let's start with the FPGA. So we need to open Quarters. We are implementing this project on Altera DE1 board and we need Quarters for building our system. So we need to give a name to our project. Let's go to next. Yes. Right now we are not adding any other files. We'll be building one of the Verilog files. We are using Cyclone 2 board. We are using Cyclone 2. We can use models in this, and we are using Verilog. Let's select it. Let's start the project. So now first we need to build our SOP system, in which we'll be using different IPs for this. So for that we need to open QCS. It takes some time to initialize. Now we need to add all the IPs which will be requiring. Let's add NEOS. NEOS will be the processor we will be using in this. And we'll be using the economic version. So now as you see, in this way we can add different IPs. Now we'll be needing a lot of ICs, so a lot of IPs. So that's why I've already built one QCS system for our project. So let's go through this system. So now in our project we'll be reading an image from SD card and we'll be displaying this image on VGA monitor. And while before displaying on VGA monitor, we'll be processing that image, and after that we'll be displaying that. So for that we need VGA controller, and we need SG Avalon interface. So we have used upclocks. Upclocks will provide different clocks for SRAM and for our system. So we have NEOS, we have on-chip memory. You can see the connections in the video. Now we need a DMA buffer for the image reading. Now I'll be providing you the link for this, which has all the information, all the theory about this DMA buffer and all other IPs. You can go through that. We need a resampler. A resampler will convert your 16-bit RGB to 30-bit RGB. We will be using a 16-bit image, a 16-bit input image of a bit file. We need a video scaler. In this we are using an image of 240 by 320, and our VGA monitor displays an image of 640 by 480. So we need to scale that image. So we are scaling by a factor of 2. Now the VGA controller works on a different frequency. It works at 25 MHz and our clock is of 50 MHz. That's why we need a dual clock buffer. And in dual clock buffer, yeah, this is the 10 colors, 10 bits we're using. We have a video VGA controller. This is our controller which we'll be using. Since we are using a D1 board, so we have selected D1, and we need JTAG UART for communication. Now we have added 3 hardware accelerators. So let me show you how to create a hardware accelerator. So let's go to new component and Just give name to your component. This is going to be my display name. Go to files and add your Verilog file. Now this is my Verilog file, so adding that and just analyze and synthesize. Yeah, so we are good for this. So we don't have any parameters. These are all the signals defined in our code. These are the interfaces. Now here we need to assign associated clock as a clock, and we have an associated reset. We are good with this. Save this. You can see we have a add one new IP. Similarly, I have built before adder, multiplier and a subtractor, and I have used this in my code. For multiplier, I have used the Mac code. I'll be providing link for this code in below this video. So after this, we need to generate our Verilog code. I've already generated this. Now you see I've already compiled my code, so that's why I've got a message of full compilation. If you see my compilation report, these are the logic elements which my code took for this. Now after this, I need to burn the Verilog code. I need to start my FPGA. Yeah, so my code is burned successfully. After this, I need to program in C, so I'll be using Neos to software. Okay, so this workspace, you need to create your own workspace. So I need to add a new application. So we need a SOPC info file. So this is the file which we get after compilation. So we need to just add that file so that it will take all the information of the project. Let's give name to our project. Let's take hello small world. So this takes time. So that's why I've already built my project. So you see here, I have created this file feature underscore news. So this is my C code. I'm using a performance counter. This performance counter I am using for counting my cycles required by my algorithm. Here I am reading my image from, I'm reading my SD card. After this I am reading one by one my image. This is the way we read the image. We are using a BMP file .bmp. So that's why we are taking each byte of the pixel, which is RGB. We'll be getting 3 pixels. After this is the implementation of the algorithm. So we have implemented all the steps shown in the algorithm. And after this we are passing this image pixels to VGA so that we can display that on VGA monitor. So let's build our project. So we have built successfully. Let's run our project. So you can see here my SD card is connected. My SD card is FAT16 file system, so it is detected, and these are the number of cycles required by my algorithm. Now you can see a small video on this video clip that shows how our image was displayed on VGA monitor. Now we have used a grayscale image in MATLAB to just cross verify our algorithm. I'll show you the output of my MATLAB. So in this, I'll be running my code. You can see this is the original image which I am using. So the process takes a lot of time to build to construct other images, the image with the feature points. So I'll show you the image which we have already, the output which we have already captured. You can see this is the output we got. This will be getting like after 5 to 10 minutes. So this is the feature point. Since this image has a lot of similar points like dark points and many dark points and many less dark points, that's why this image gives a lot of feature points. We have again implemented the same code for another image and we have got the result like this. So this is the image, and these are the feature points which we have got. So in this way we confirm that our algorithm is working and we are getting a proper output. If you have any issues, just message me in the comments. I'll be sharing number of links for related to this project so that anyone can overview over this. I'll be also sharing a link to a channel from where I've learned the basics of Waters and FPGA. You can refer to that to build your own project. Thank you.